So we're going to do the antiderivative of 1 plus x squared over x times the quantity 1 plus x the quantity squared dx. And we're going to treat this as a partial fraction decomposition. So the first one is just going to be a over x, that's using this factor. Here we got a repeated linear factor. So the way we handle that is we need to account for each possibility. So b over 1 plus x plus c over 1 plus x the quantity squared dx. Now, I know this is a square here, but this is just a repeated linear factor. And every time you have a linear factor, you just need a constant on top. You don't need any x terms. So that's why it's just c up there. So now we multiply each of these by what it needs to make that least common denominator. So the a gets multiplied by 1 plus x, the quantity squared. The b gets multiplied by the x and one of the 1 plus x's. And the c gets multiplied by just the x. And the numerator we want it to be equal to is 1 plus x squared. So multiplying all this out and distributing the a's and the b's and the c's, we're going to get a plus 2ax plus ax squared plus bx plus bx squared plus cx equals 1 plus x squared. And now we're going to group these to make our system. I like grouping them by powers of x. So first off, the x squareds, we have an a plus b, no c, and there is an x squared over here. There's one of them, so 1x squared. Next come the x's, so 2a plus b plus c, and there are no x's over here, so that must equal 0. Last one is our x to the 0, so we have a, and that's it, and that must equal our constant term of 1, so we actually already know that a equals 1. Well, if a equals 1, then b has to be 0 from this first equation, because 1 plus b equals 1, b must be 0. And that's going to give us enough to solve this one, because subbing those in, we get 2 plus 0 plus c equals 0, which yields a c of negative 2. So we've got our a, b, and c. This term actually is going to disappear from our final answer. And that happens sometimes, especially with a repeated linear factor. So we get the antiderivative of 1 over x, plugging the 1 in there, plus 2 over 1 plus x, the quantity squared dx. You might want to rewrite this as a power function. So 1 over x, excuse me, not plus 2, or let's write it this way, plus a minus 2. So plus a minus 2 times 1 plus x to the negative 2 dx. We'll put the negative in the next line. Sorry about that. So the antiderivative of 1 over x is the natural log of x, excuse me. Antiderivative here, well, we've got the minus 2. This is going to become 1 plus x. You increase the power by 1, divide by the new exponent, plus c. So that's going to swap the sign here. And our final answer is going to be ln of the absolute value of x plus 2 over 1 plus x plus c. So we just wrote that back in the denominator because of the negative 1 exponent.